Welcome students. In this video we'll try to learn about the inverted YouTube manometer, and also we'll try to solve one or two sums so that we'll have a better understanding of inverted YouTube manometer. So a differential manometer is something that is utilized to give you the output as the difference of pressure in A and B. So rather than showing what is the pressure in A and B, the differential manometer will show you the difference in pressure between 2 points. So this is what we have seen. So a differential manometer is of two types. One is your normal one where you'll have the pipe A here. We'll have the pipe B somewhere here, or maybe it will be the opposite. Maybe the pipe B will be at the top, then the pipe B, or it may be even at the same level. So you have pipe A, which is pressure A here. The pressure, this will be pressure B. So there will be fluid 1, which is your metered fluid 1 flowing through A. And there may be a different fluid or the same fluid, depends upon the usage. So this is metered fluid 2, and there will be a manometric fluid which we'll use in between these two, which will act as a member to show the difference in pressure. So the difference in fluid level for manometric fluid H, and also the difference in height helps you to find the pressure. For example, now this is my level 1, this is my level 2. Now the pressure at this point, maybe I take this as my reference plane XX, the pressure at this point, since the fluid is at equilibrium now, the pressure at this point is equal to the pressure that is acting at this point. So the pressures are equal. Now equating the pressure on my left hand side limb, I have PA plus rho 1. Let me take this as rho 1, the fluid 1. This is rho 2, the fluid 2, and this is my metered fluid. I'm going to take it as rho G. So PA plus the pressure due to the height. So this is H1. So rho 1 GH1 should be equal to the total pressure at my left hand side, that is, sorry, right hand side, that is PB, plus this will be my H2, that is the fluid height level of fluid 2. So rho 2 GH2 plus this is a manometric fluid, which is rho G. So the density rho G, G into H. So this is the equation. Rather than remembering it as a formula, you can remember the logic which will help us to solve the sums. Each sums you could actually develop the left hand side and right hand side and equate it, and you could solve it. Now the second one that we are going to see is an inverted YouTube manometer, which will be utilized to find the pressure difference of a low pressure fluids. So again, we'll have like this. So this is the pipe A. Since as the name suggests, it is an inverted YouTube manometer. So the tube is inverted. So this is an inverted U. So we have pipe B here. This is B, this is A. So this is the inverted YouTube manometer, which will be connected to two pipes A and B to measure the flow. So this is A, this is B. So this is pressure B, this is my pressure at A, and there will be again three fluids. Sometimes the two metered fluids may be same, as the manometric fluid has to be different. We may have a manometric fluid here. So this is my manometric fluid. In general, we'll use mercury. This is the manometric fluid. This is my metered fluid 1, which is flowing through A. Or you can even name it as rho A. Instead of naming it as rho 1, it is also rho A. Anyway, we'll be substituting the value. So if you know the value and you know which one is what, that is more than enough for you to solve the problem. This is my fluid that is flowing through pipe B. That is my rho 2, or even you can name it as rho B. So this is rho 1, rho G, and this is rho 2. So we have three fluids which is flowing The third fluid is actually the manometric fluid is in the UT manometer, which will help us to find the pressure. So let me take this as my reference point XX. So this is my reference point. Now the heights will be, this is my height H here. So this is H1. From this point to this point, I have to take different height as the fluids are different. So this is H2 and this is my difference in fluid level H. Now the major difference here is this is below the pressure here, right? So in the previous one, the pipes were at the top and the U tube at the bottom. Now here it is different. So we have to start like this. Let me take the pressure here should be equal to the pressure here, which is the pressure that is acting. Now let me take this as PA dash. This is just for the sake of understanding, and this is PDB dash. Now my pressure at PA, that is my pressure that is at the bottom, should be equal to PA dash plus rho 1 GH1, because if I have to find a pressure at a particular point and I know the pressure at the reference point which is at the top, the more I go below, the pressure increases. We have derived this P is equal to P naught plus rho GH. So we are using this formula. So PA dash plus rho GH1, that is rho 1 GH1, will give me my pressure at PA. The same way, PB dash plus rho G rho G GH plus rho 2 GH2 should be equal to PB. That is my pressure at this point. So that's the pressure I'm finding. So now my PA dash is equal to PB dash. As I have stated, this is the point where the pressures are equal. So I have to rearrange this as PA dash is equal to PA minus rho GH1. My PB dash is equal to PB minus rho 2 GH2 minus rho G GH. So technically I have to just take negative signs instead of positive signs. You can remember this in chart. So if you directly take it, I will take it as PA minus, since I am going up, I have to take it as minus rho GH1. Rho 1 GH1 should be equal to PB minus rho 2 GH2 minus rho G GH. This is my formula that I can employ to find the unknown data. For example, they may give you the value of H and ask you to find the pressure difference, or the pressures may be given. So since we are intended to find the pressure difference, you can still rearrange this equation to find PA minus PB. So my PA minus PB is equal to rho 1 GH1, that is, since I am having PA as positive, my rho 1 will be positive. This is again a hint for you. PA positive minus PB is equal to, this rho 1 is taken to the other side, so the negative will become positive, minus rho 2 GH2 minus rho G GH. This is the formula I can employ. But again, as I have mentioned, rather than using it as a formula, deriving the formula for that particular condition, given condition, will be easy in terms of solving the problems. Now with this, we'll try to solve one or two problems. So we'll solve this question. Question is, find out the differential reading H of an inverted U-tube manometer containing oil. So generally we will be using mercury. Here the differential manometer has the manometric fluid. So as we named it as manometric fluid and metered fluid. Metered fluid is the fluid whose pressure as we are finding about. So we have the oil of specific gravity 0.7 as the manometric fluid, which connected across pipe A and B as shown in the figure. We'll see the figure in the next slide. Conveying liquids of specific gravity 1.2 and 1.0. So we have three fluids here. Maybe density 1 is 1.2 into 1000. That is 1200. As we know, density is equal to specific gravity into density of standard fluid, where here it is liquid, so it will be water, which is 1000. So your density of second fluid is 1000, as it is specific gravity 1 kg per meter cube, and the manometric fluid rho g is specific gravity 0.7, that is 700 kg per meter cube. These are the densities of all the three fluid that is being used. Immiscible, that is the fluid doesn't mix with each other. Pipes A and B are located at the same level, and assume the pressure at A and B are equal. So we have the pressure at A and B is equal. That technically means PA minus PB is equal to 0. So we could utilize those to find the unknown. So this is the diagram as the question stated that is given. So this is the diagram that is given in the question. So for this only we have to solve. So we have to find this height h. It is given 30. That technically means this is also 30 because it is given the pipes are at the same level. So we have to find the h. So as I have stated, instead of utilizing a formula, we will derive it. So this is my reference point. Maybe this is my reference point because only above this, all the fluid is the same. If I take this as my reference point, this side I have two different fluid. So taking it will be making it more complicated. And as stated in the derivation, the pressure that is acting here is equal to the pressure that is acting here. So since we are equating that to, my left hand side pressure is PA minus rho 1 GH1, which is 30, minus rho G GH. So I have taken my left hand side pressure. Since there are two different fluids here, this one I have taken it as rho 1, this I have taken it as rho G. So rho 1 is the fluid in the pipe A. So we have to take that density. Now this should be equal to my PB, that is my pressure here, PB, minus rho 2 GH. That is my H2 is technically 30 plus H. So I can directly substitute that as 30 plus H. That is my total height of the fluid column. So this is my total height of the fluid column, which is 30 plus H. So now I have to equate these two. So equating these two, PA minus rho 1 GH1 minus rho G GH is equal to PB minus rho 2G into 30 plus H. This is my left hand side limb, this is my right hand side limb. Now since PA equal to PB, this is PB. PA minus PB is equal to, I'm taking these to the other side, so this will become rho 1 GH1 plus rho G GH minus rho 2 G into 30 plus H. Now this can be cancelled. So rho 1 GH1 plus rho G GH minus rho 2 G into 30. This is also 30. Minus rho 2 GH is equal to 0. This is my equation. Now my rho 1 is 1200, my rho 2 is 1000. And yeah, so substituting that, my equation is rho 1 is 1200 into 9.81 into 30. Is it in centimeter? Yeah, so I have to convert this into 10 power minus 2 meter. So this is my value of this. So I have to be careful. Since this is 30, this will be 0.3 meter. This is 0.3 meter. This should be H. We can keep it as H because anyway the final answer that we'll be ending up with will give us the value in terms of meter. So this is 0.3 instead of 30 into 10 power minus 2. I'm taking it as 0.3 plus rho G, that is 700 into 9.81 into H, which I don't know. That's what we have to find. Minus rho 2. My rho 2 is 1000 into 9.81, that is my gravity, into again 0.3 minus rho 2, which is 700 into 9.81 into, sorry, my rho 2 is 1000 into 9.81 into H, which I don't know, which is equal to 0. So keeping H on one side and the other values to the other side, this will be 700 into 9.81 into H minus 1000 into 9.81 into H is equal to, taking this to the other side, 1000, this I am taking it to the other side, since it is negative, going there as positive, 1000 into 9.81 into 0.3 minus 1200 into 9.81 into 0.3. Since 9.81 is there in all the terms, I can cancel it. So this will be minus 300, because 700H minus 1000H is minus 300H is equal to 1000 into 0.3 is 300, 1200 into 0.3. So minus 1200 into 0.3, that is 120 into 3, 360. So since both are negative, I can write it as 60 equal to 300H. So H is equal to 60 by 300, which is 6 by 30. I may end up with 1 by 5. So 1 by 5, which is technically 0.2 meter. So the value of H is 0.2 meter, or I can write it as 20 centimeter. So this is the answer. So we have found out the value of H. So when you have the pressure at these two as the given value, which is they are equal, then this will be 20 centimeter. So this is the answer for question number 1. Again, we have derived the formula at pressure for 2 at the top level, equated it, simplified it, and got the value. The only place where you have to be careful is converting centimeter into meter, which you have to do it. So this will be 0 0.3, 0 0.3, 0.3, 0 0.3. So this is your solution. Now going ahead with the next question. Now we have an inverted U-tube manometer which is connected to two horizontal pipes A and B, through which water is flowing. So technically your rho 1 equal to rho 2 is equal to 1000 here, as water is flowing through both the pipes. The vertical distance between the axis of the pipe is 30 centimeter. So we have the vertical distance as it. In the previous question, the levels were same. Here, one pipe is 30 centimeter below the other. It need not to be A or B, as it is a difference. So we could take either A or B at the top. When an oil of specific gravity 0.8 is used as the gauge fluid, that is a manometric fluid, the vertical height of the water column in the two limbs of the inverted manometer are found to be same and equal to 35. So the vertical height of the water columns in the two limbs, that is the difference between the water level in the two limbs, is 35. Determine the difference in pressure between pipes A and B. So we have to find the difference in pressure between A and B. As I have stated, if we take A at the top and B at the bottom, the difference will be positive, right? And if you interchange it, it will actually change the sign. That is, as we are finding the pressure, we will be worrying about the difference in pressure rather than PA and PB separately. So to draw the diagram, as it is an inverted manometer, let us draw the manometer first without worrying what are the values of the heights. So all we have to be careful is one pipe is at a distance of 30 centimeter from the other. So I'm taking the one pipe. I didn't name it yet. So I'm going to take one pipe below the other. So this is my diagram where I have the pipe. Let me take it as A here, pipe B here. That technically means my PA is slightly above than PB. So I have this distance. The distance between the center of the axis is 30 centimeter. Now here I have water up to a certain level. Here I have water up to a certain level. Now as we know, the pressure at A will be on a lesser than the pressure at B. Right? The pressure at A will be lesser than the pressure at B, because from a reference point, the more bottom I come, the more the pressure will be. So the pressure at B will be lesser. So let me take this as my manometric fluid. Yeah. Now as you can see, the pressure at PB is greater than pressure at PA. So this pushes it with a larger distance. As you can see, the height from this to this is a larger compared to this to this. Now the distance between these two is 30. Now it is given that the water level is from the axis is 35. So as you can see, the value of vertical heights of water columns in the two limbs of the inverter manometer when measured from their respective center lines of the pipes. So there is one more term which is given. So the vertical heights of the water column in the two limbs when measured from their respective center of the pipe, from their respective center of the pipe. This is a term given in the question. So that technically means from the center, this is 35. From the center, this is 35. So that means this gap is 5. So now we have almost all the data. So this will be, so since this is 5, this has to be 30, because from the center up to this is 30. So this is 35. So another 5 is here. From here to here, reference level, this is 35. So this has to be 30. So now we have almost all the data that is required so that we could solve it. Now the pressure at my left hand side limb is PA minus rho water. So rho 1 G H1. That should be equal to my PB minus rho 2 instead of rho 2. I'm taking it as rho 1 because the fluids are equal, or you can take rho 2 here and then finally substitute 1000 on both the sides. Rho 2 G H2 minus rho G GH, which gives me, now my density of the fluid that is flowing is 1000. So PA minus PV, the difference in pressure is equal to rho 1, which is going to the other side as positive, 1000 into 9.81 into H1, that is 35, minus rho 2 again 1000 into 9.81 into H2, again that is 35, minus rho G, which is 13, or no, the oil that has been used is of specific gravity 8.8. So 800 into 9.81 into, that is 30. Again, all are in centimeter. So this will be 0.35, 0.35, 0.3. So these are my values. So my PA minus PB is equal to, I get 1000 into 9.81 into 0.35, 1000 into 9.81 into 0.35, cancelling each other. So I'll be ending out with minus 800 into 9.81 into 0.3. Calculating this value, I'll end up with 800 into 9.81 into 0.3. 2354 minus 2354.4. That technically means my pressure as B is greater than PA, and from the diagram itself we knew it, because the more the depth you go, the more is your pressure, because pressure at any point at the bottom is equal to pressure at a particular top level plus rho GH. So that technically means the more down you go, the more is your pressure. So I can write this as PB minus PA, technically indicating that my PB is greater is 2354.4 Newton per meter square. This is my final answer. Again here, instead of taking it as a formula, we have derived it. The only place we have to be careful is converting this into meter, and also it is given in the question that when measured from their respective center of the pipe. So it was 35 from a reference point. These two are reference point. So from here it was 35, and we have converted everything accordingly and solved it. So since PB is greater, this total height that to which it is pushed, even though this is slightly lower than this level, as you can see, to rise this up to a certain level, it should need a pressure. Now the pressure that this is being subtracted is quite less, only this height, whereas this has to overcome this much height. So the levels are equal, so 35 and 35. So they mercury, that is the oil level here, it's slightly down, but according to the total condition, the pressure PB is greater than PA. That's why the level of fluid is above the pressure at A level. Now, in case my pressure A is greater and this is down, this should have brought it down than the PA level. It should have pushed it more down here. Since that is not there, we have to draw this diagram like this. So you have to be careful with the diagram. So that's it. We have seen how to use an inverted U-tube manometer, and we have solved two problems for inverted manometer. Thank you. Happy learning.